Hi friends, good morning. In the last session, we discussed the private. Finally, we discussed the private, public, and the protected access specifiers. The next one is variable length arguments. Normally, whenever we are passing values from the calling statement to the method call, we can pass variables right in terms of fundamental types. By short, int, long, like that, we can pass the values in terms of fundamental types. There should be correspondence between the actual parameters and the formal parameters in terms of the number of parameters, the type of parameters. Because Java is said to be a strictly typed language. The number of parameters and the type of parameters should match in the order from left to right. In some cases, what we could means we can pass the array as a parameter. Whenever we pass the array as parameter to a calling statement, sorry, to a particular method, you need to specify just the array name, right? So specifying the array name, completely what happens means the entire array is passed as a parameter to the function definition. So in that case, actual parameter should be the array name. Formal parameter, what should you do means you have to define the formal parameter like this: data type, array name, then specify the subscripts. Do not specify the size. Size should not be mentioned in the formal parameter. In our case, right, what happens means the actual parameter is completely assigned to the formal parameter. So in that case, the formal parameter can be processed within the method definition. So this kind of methodology is said to be a variable length arguments or simply var args. We can pass variable length arguments during the method call. So 5 arguments, 7 arguments, 8 arguments. We can pass any number of arguments. That means when the entire array is passed, array name is passed, the entire array elements are passed as a parameter to the formal parameter. In this example, consider the class pass array. We have defined a method void test. Formal parameter type is integer x array. Actual parameter is defined here. For example, ch1 array, some character array initializer is provided. ch2 array and ch3 array. Then one integer array is defined. Another one int a array is equal to empty. No element is in it. We are calling the test method by passing these actual parameters ch1, ch2, ch3 and e. So simply array name is mentioned ch1, ch2, ch3, e. The entire array elements are passed as actual parameters to these formal parameter, say x. X receives the entire array. For example, pobj.test of ch1 means the entire array is passed as a parameter to this formal parameter x. Simply x receives the value of ch1. We do want to find the number of elements in the array that can be found using the length instance variable, array name dot length instance variable. Then for into j a colon x. This is a simplified version of for loop. Here, what is j means? J is an iterator. The iterator j iterates the elements in the array x. So int which indicates that the type of the array x is integer 1, not to the variable j. Type of array is x. The type of array x is integer 1. So integer is mentioned here int. J is an iterator which is used to iterate the elements in the array x. So after the for, if you print a value of j means return initially x of 0 is printed. Then next value of j, right? J plus plus x of 1 is printed, x of 2 is printed. In that way, the entire array elements in X array are going to be printed here. Understand or not? First x of 0 is ch1 of 0, right? A. Then this is x of 1, x of 2, x of 3, x of 4. So that array elements are printed here. Let us run the code. Java masses 21. First array is ch1. ch1 is received here. Length of ch1 is 1, 2, 3, 4, 5. The value of ch1 contents are printed here. Since this is an integer conversion, character to integer 1, corresponding integer values are printed. Next array is ch2. ch2 is a character array. Character to integer conversion is taken place. Then integer values are printed. Third one, ch3, simply an integer array having 10 values. So array size is 10. Contents of that integer array is printed. Last array, a array, which do not have any elements, right? So in that stage, the content of an array A is empty, so no content is printed. Number of arguments is 0 because no element is in it. In the array A dot length results in a value 0, so 0 is printed, but there are no contents in that array. Having any queries in this example? Of course, in this example, right, we have illustrated how to pass the entire array as the parameter to a method, formal parameter to a method. Here, do not specify the arrays. Having any queries in this example? Having any queries?
No,
Okay,
sir.
I move on to the next one. Uh, Very good. Here in this, we do want to introduce right, one more separator. The separator is, okay, this next one, 22. There is one separator in Java that is said to be triple dot operator. Last class we have seen, right? Once again I explain this. This is said to be ellipsis separator.
Sir,
Ellipsis separator. Yeah.
sir,
Yes.
sir, your voice is
Yes.
low, sir.
Okay. Is it okay now?
Yes, sir.
Okay. The ellipsis separator is defined using triple dot notation. The purpose of ellipsis separator is variable. The name given to this of a separator is variable arity separator or variable arity parameter. The purpose of the variable arity separator or parameter is we can receive any number of actual parameters into the corresponding formal parameters array. For example, here in the previous example, we have mentioned here 5 initializers, 6 initializers, say 10 initializers. The corresponding array is actual parameters are received in the formal parameter array. Here what happens means instead of passing the array name, hope you understand, instead of passing the array name, we are directly passing the array initializers as the direct actual parameters. So here in this example, pobj.test, some character values are passed as actual parameters. Java is a strictly typed language. You know that there should be a correspondence between actual and formal parameters. Is it? So actual parameters 1, 2, 3, 4, 5 means you need to specify exactly 5 formal parameters. 1, 2, 3, 4, 5. I think okay. These are of a character type. So at least here you need to specify a character variables, 5 character variables. If not, you need to specify say some 5 integer variables from lower type to higher type. Here if you do not specify right five character variables or some five integer variables, we can simply specify the ellipsis separator to indicate the variability parameter. So in that stage, what happens means you can specify variable number of parameters during the method call. Means we can specify any number of actual parameters in the method call. Those are completely received in the formal parameters. Formal parameter, what about x means? X is considered as an array. X is an array type. As usual, starting index is 0, last index is actually determined by length minus 1. Suppose 5 elements are passed here. 5 minus 1 up to 0 to 4. 0 to length minus 1. So x of 0, x of 1, x of 2, etc. x of length minus 1. Hope you understand. The syntax is this one. Data type, triple dot, then that is ellipsis separator, then specify the array name. Actual parameters can be of any actual parameters can be the same type. Here integer means here write a same type, or there should be a type compatibility. The number of parameters are not limited. You can pass variable number of parameters. All of these actual parameters are simply received in the formal parameter array x. Understand?
Sir, your AEIOU will be converted into ASCII values, sir.
Yeah, the AEIOU are all converted into the ASCII values because of type promotion, character to integer. The concept is you need to understand this one. 0 to length minus 1, right? These are the array indices. Because of these ellipsis separator. Even this concept is supported only in the latest versions of JDK. In the earlier versions of JDK, this variable length arguments concept is not supported. So here,
Sir.
first one, we are passing some 5 character values. These are processed here. This is similar to right the previous code. Only the change is right here. This is changed. Instead of int x array, we simply used int triple dot x. In case, listen, int triple dot x, this is changed to int x array as we did in the previous example. This results in a compile time error. You please try to check that because here the actual parameters are of a variable type parameters. In that stage, two things. Either you have to specify the exact formal parameters. 5 means there 5. If not, you do you need to specify this kind of variability separator. Second one, right, we are passing some parameters. Third one, right, we are passing some integer values. And the last one, right, we do not pass any values. So in that stage, here the array receives the total length of elements is simply 0. So if you run the code classes 22, you will be getting the same output. Java C classes 22.java. In Java classes 22. Seeing the results right, the same output is produced in both the programs. So what is the advantageous one means here this is most advantageous compared to the previous method. Specify right any number of or simply variable number of actual parameters. Corresponding formal parameters should be defined using variable separity, variable arity, right? Variable arity is separator. Syntax is this one. Data type triple dot that is ellipsis separator. Then specify the array. So having this as a fundamental concept, right? We can go for overloading the variable arity separator methods. For example, void test, int separator, float separator, say byte separator, long separator. Likewise, we can go for overloading. So passing integer values, integer version will be called. Passing character values, a character version will be called. Let us check that. The next example. How to overload a variable arity a parameter methods. For example, here integer version is defined. While overload test. Assume overload test is a method. Int ellipsis separator, then array name is x. Integer array contents are printed here. Same method I have defined here. Only the difference is an integer type is changed to floating one. A float x. Floating point array contents are printed here. Same overloaded version. Same method name. Integer parameter. Here it differs in a floating point parameter, and another one differs in the Boolean parameter. The contents of the Boolean array are printed. As I said earlier, here array type x is integer 1. So iterator variable, right? J should be integer 1. Array type x is a floating point 1. So here iterator j is a floating point 1. Don't think j is a control variable of for. J is simply the iterator variable, right? So this should be defined the same floating point type. Here also, right? Usually, right, we prefer to write for int j or float int j, right? That will result in a compile time method. Here also, right? Boolean x is of a Boolean array, right? So iterator j is a Boolean type. Simply you are printing the iterator j means initially x of 0 is printed, then x of 1, x of 2, right? For each value of 1. Now have a look into right the main method. In main method, we are passing the same values, right? Overload test, character values, then floating point values, then some Boolean values. Overload test, right? Here this is what one method name. Here also this is the method name. This is the method name. During the compile time, the compiler determines the right method to be called. Here passing some character values, the character version is not available, so integer version is included. Passing some floating point values corresponding to the floating point version is called. If the actual parameters of the Boolean type values, right? So there are right our variable arity method is defined with Boolean parameter array. So Boolean version is called. One like one interface, multiple methods, aspects of a polymorphism. Java C classes 23.java, then Java classes 23. So first stage, what happened? The integer version is called because character to integer. Then a floating point version is called, and then the Boolean version is called. So this is said to be overloading using ellipsis separator or variable arity parameter. Understand? Understand or not? Now
Yes,
let
sir.
us
Yes,
check
sir.
right how the ambiguity is raised respect to this kind of variable arity separator. Same example, right? Whenever we are passing the integer actual parameters, integer version is called. Passing floating point actual parameters, floating point version is called. Passing Boolean parameters, Boolean version is called. The question is when we do not pass any actual parameter. Hope you understand. When the actual parameter is empty, say pobj.overload test empty. In this stage, what will happen? This is the question. So when the number of actual parameters is 0, right? Here, will it be received in a Boolean or float or integer one? That is the question. Of course, this results in the ambiguity between method calls obj.overload test, right? The error is reference to overload test is ambiguous one. So what kind of ambiguity is raised in this code? To call a float version or to call a boolean version uh, and one more version. What is version? What is that? Integer version, right? So both method here write a float and a boolean in pass array overload match because of this default uh, empty parameter, right? So versions are going to be matched for float as well as boolean. So this results in the compile time error. You can ask why not integer type is mentioned in case when boolean is commented or slash java again, right? What happens?
Sir, comment that line, sir.
No
Boolean
suitable
line.
method found for yeah. One error is removed, I think it will be removed. Okay. Then Java classes 24. What happened? One, two, what is the third line? Overload test. Overload test. Number of arguments 0, contents empty. So in that stage, right, what happened? The which version is actually called?
Float.
To check that, right, you need to mention a message system dot out dot println float is called. Recompiling and running. First stage, what happened? The calling statement. Calling statement is of EIOU. The integer version is called. Next, passing floating point values. Float version is called. Number of arguments, floating point. Then number of arguments 0. It seems that the integer version is called. Int is called here. Change it to. File has been saved. Compiling and running again. Finally, right, it seems that the int is called. So in this case, right, there is no ambiguity because here overload test of empty, right? This is taken for the first version, integer version. In case if integer version is not available, then it will be taking and the floating point version. But unexpectedly, right, if the boolean version is given, then true false because of these values, right, to true false, there is an ambiguity between the floating point version and the boolean version. So you try to carefully understand this situation, ambiguity situation. Another kind of ambiguity situation is illustrated in this example. This is a different ambiguity situation. The same as the previous method, void overload test int x, right, variability parameter. Here int a comma int x. There are certain restrictions when using this kind of ellipsis separator, right? The restrictions are you need to specify this as the last parameter. Hope you understand. Int triple dot x. This would be the last parameter. If in case if you are specifying int triple dot x, comma, say float a, this results in a compile time error. In C++, you might have studied default arguments. Default arguments can be set from right to left direction. Likewise, here the rule is the ellipsis separator should be defined in the method definition from right to left. And how many number of that you can specify in C++ more number of default parameters. But this ellipsis separator, right, is concerned. Only one separator should be introduced. Do not specify like this. Int triple dot x character triple dot ch. This is not allowed. Only one ellipsis separator is allowed. That should be the last parameter of a method declaration. This is very important rule. So int triple dot x, this is perfectly okay. Here int a comma int triple dot x, this is also okay because int triple dot x is acting as a last parameter. Int a, character a, float a, int triple dot x. This is completely okay. Understand or not? Now the thing is, if you specify right the variable number of integer values, automatically this integer array version is called. What is the meaning of this overload test? Just think of instead of int character is there, or because integer to character, or you have to pass exactly a character value, or consider a floating point value float a. Suppose the actual parameter is say 10.0, comma 20, 30, 40, 50, no problem. This 10.0 as a floating point value. So a floating point version, this version is invoked. Remaining values are assigned in the XORA values, X of 0, X of 1, etc. Now instead of this float, let us have the same int version. Here int a, int x. What is the difference between int a comma int x comma int x? Logically, it seems that more number of integer actual parameters are received in this integer array x. Integer array x. Here, the logical meaning is first parameter should be of integer 1. Subsequent values should be of integer array. That is the meaning. How can you distinguish 1, 2, 3, 4, 5? For example, to call the exact version of the first one, or assuming that I do want to pass 1 into this integer variable, say a, starting from 2, 3, 4, 5 into this integer array x. Is this allowable to the compiler? So this stage, what will be the status of a compiler? Can you predict how a compiler treats this situation? Passing the integer values completely assigned to the first person, or only one value to the a parameter, and the remaining values to the xarray parameter. Any guess, prediction? This results in the ambiguity error. Obj.overload test, right? This is an ambiguous one because both methods are matching actual parameters 1, 2, 3, 4, 5. These are matched with the parameters of these two versions, int xarray, int comma int xarray. So this situation arises the compile time error. Since twice we have used right overload test, so it seems that two compilation errors are produced. First method call and even the second method call also results in the compile time error. Understand or not? Suppose let us check this into a float. Float A, assuming that one parameter is the floating point 1. In this stage, Java C classes 25.java, Java classes 25. Have no problem, right? First version is invoking, sorry, first method call is invoking first version, integer version, because 1, 2, 3, 4, 5. completely taken as integer values called the integer version. Second one, first one is a floating point value. So floating point version is called here, right? Then 20, 30, 40, 50 are alone stored into the variable X array. So X array contents are 20, 30, 40 and 50. Understand or not? This is another situation using the ellipsis parameter or ellipsis separator to raise the ambiguity error. Hope you understand the latest concepts, right? Using the ellipsis separator, which is not supported in the previous JDK versions. Having any queries? Yeah,
Sir,
any
in the
queries
last case, sir, when we
otherwise we move on
specified
to the
Boolean,
next
sir.
topic.
Excuse me, sir.
The last
Sir, in the
case,
last case, when we specified Boolean, we got an ambiguity error, no, sir.
yeah, tell me.
Sir, but again, we got an ambiguity error between Boolean and float, no, sir.
Yeah,
That compile error was showing the ambiguity between the Boolean.
yeah, it shows that's what I said. Boolean and float. But right, then we changed from Boolean is commented out.
Yes,
So
sir.
in that
Then it
stage,
should
right, what will
be.
happen means we have tested out, right? This called the integer version. This is called the integer version. So by default here, when the number of actual parameters is 0, this calls the integer version. But when you have the floating point as well as Boolean, because of I said Boolean assumes true false values. Now there is a match between the compiler is treating, right, the match between float and Boolean one when 0 parameters are passed. So we have to learn those things, right? So try to pass exactly right the required number of parameters and understand how the ambiguity error is raised, right, between float and Boolean, and no ambiguity error is raised using this method call when having only integer and floating point versions.
Sir, if float is commented out and if we have only int and Boolean, we'll be getting an ambiguity error, sir.
If which one is
Float is
commented out?
commented, sir, and we are having
Float is commented
the
out.
int and Boolean.
1 minute. We need to check it. Let us check it. Float is commented out. Having which one? Int and Boolean. Let us check, right, how the compiler is reporting. File name is
Sir, you
24.
should remove that floating point variable, sir.
Sir,
Java.
comment the float statement, sir. In main.
Which one? Method call.
Main.
In main, sir. In main.
1 minute. I
Comment
have
that
to
float,
close
sir.
this. Let me close it. Oh, wait. 1 minute. Let me close this slide. Classes 24. I think I have to 1 minute. Let me close it and open it. Classes 24. Yeah, float version is commented out here, right? Floating point 1. This is commented out. Boolean version, no problem. We have it. Testing for 0 actual parameter. Overload test is ambiguous. Both method int as well as Boolean is matching.
Okay,
0
sir.
parameter, int as well as Boolean is matching. But in the previous case, what we have observed, only Boolean is commented out, right? So commenting only Boolean. In this case, int version is called. Am I right? Our classes. called the inversion. So here the ambiguity is raised between int and boolean also. So commenting float, right? Integer and boolean ambiguity error is taken. Are having a float and boolean ambiguity error is raised between a float and boolean. Only thing is when boolean is commented out, right? So having integer and floating point version here by default integer version is called without any ambiguity. So try to note these kind of ambiguity errors. And having any other queries, I'll be passed on to the next topic. Classes 25. Okay. So next we are passing on to the new topic, code reusability, that is inheritance. Inheritance you might have studied in the C++, deriving the features from one base class into a new class. In C++, the relationship is a base class and derived class relationship. What is the advantage of code? Advantage of inheritance means code reusability. For example, you know that for example, you have written a code for sine series, and you have written a code for cosine series. You can directly write for tangent series, right, by performing sine series divided by cosine series. Tan x is equal to sine x by cos x. The code can be reused, right? You need not write the code again. So the main advantage of inheritance is code reusability. Once the code has been returned, whenever, wherever it is required, right, we can call the code which has been written earlier. That is the advantage. So same concept in Java inheritance. Java supports simple or single inheritance. The relationship in Java is a superclass subclass relationship. Base class in C++ is said to be a superclass, and a derived class in C++ is said to be a subclass in Java. I directly illustrate, right, what is a single inheritance in Java. See the class, right, a class triangle. Let us fix, right, this as a superclass. That means from which we can derive the features into a new class, so that class triangle is acting as a superclass. Some instance variables are defined, a double xy area, and so to illustrate, right, private variables are not inherited. We have one private variable, private int z is equal to say 3. Then compute method, let us compute the area of a triangle, say half bh, half b into h. X is the base and y is the height of the triangle, for example. Then inside the display method, we have printed the contents of the area. Area is equal to plus area. Now the class rectangle is defined, right? For example, we do want to access the features of these variables, x, y, area, into a new class, a rectangle. So rectangle also takes some parameters, length and breadth. Instead of having the new declarations, length and breadth, we do like to use the variables, instance variables that we have declared earlier in the triangle class. So for that purpose, what we have to do means Java defines the simplest style in performing simple inheritance. Class name, new class name, extends super class name. What is extends? What is extends?
Sir, it inherited from triangle.
Extends, yeah,
Keyword.
extends is a keyword, right? Normally, right? Extends is a keyword in Java. The keyword which is used to support the simple inheritance. So the syntax, right? You try to recall, right? The syntax is class name extends super class name. In C++, right? The syntax will be a different one. Class derived class name, then colon. What you have to do? You need to specify the access specifier.
Access.
In what mode you do want to derive the features from base into the derived class. Access specifier, then you need to specify the derived class name as an access specifier. Class derived class name colon access specifier, sorry, base class name should be mentioned. If you want, you can also pass, right, some parameter to the constructor of the base class. That is possible, right, here in Java also. So in the simplest level, right, class name extends uh, the super class name. The class name, this is said to be a subclass name. Extends is a keyword. This means that, right, the entire public members of a triangle class are completely available or inherited into the new class rectangle. By default, double XY area are public members of the class triangle, and compute area display, right? These are the methods again available in the class rectangle. So to compute the area of rectangle, we need the instance variables length and breadth are actually not defined inside the class rectangle. So directly we are computing the area. Area is equal to x into y. Of course, right, we can ask what are x and y. X and y are actually inherited from the superclass triangle. We can initialize x and y because this is public. Here, right, this is public. Inside the main method, we can initialize directly rectangle class object to the instance variables x and y. Then disk, right? Disk, right? For example, a new method computing the area of rectangle. And if you want to call display, right? Inside the disk, we can call display. One method can call another method because just to think of this highlighted version is again available inside the class rectangle. So thinking that, right, the rectangle class object can have the rights to access the compute and display methods, or even compute or display can also be called inside any of these methods. Now triangle class object, say T is created, triangle T is equal to new triangle, T dot X is initialized and T dot Y is initialized. T dot compute and T dot
Sir,
display.
in triangle
This
class,
calls
we need not
S1
mention the public
super
void.
class version. Being a not no need to mention public void, right? I just mentioned, right, to illustrate, right? A
Okay.
public void means, right, again this will be, right, a public version inside the class. Which one? Rectangle. Public void compute, this is same as void compute, no problem, because by default the members of a class in Java are public with respect to same package. Later we explore the concept of packages, right? After inheritance we will explore the concept of packages, because in the same package, right, public not necessary. So by default void compute is same as public void compute. So here, right, the class rectangle is a subclass of a superclass called triangle. This does not mean that triangle class object cannot be used to access the methods of the triangle class. So triangle class object can have the rights to access its own methods independently, right? There is no error in this case. Triangle class object is created. Using triangle class object, you can call the methods or instance variables of triangle class with respect to its accessing groups. So triangle class t dot compute t dot display is called. Then coming to the rectangle class object, rectangle r is equal to new rectangle, r dot x is equal to something, and r dot y is equal to something. Because r dot x, right? Because of here x and y are actually inherited from the triangle class, because x and y are public instance variables of the triangle class. You just think of double x comma y comma area is same as public double x comma y comma area, and this highlighted declaration is again available in the class rectangle, because extends triangle superclass features are inherited into the class subclass, say rectangle. So rectangle class object can have the rights to access these variables x, y, and the area. So rectangle object dot x, rectangle object dot create another variable y, right? These are valid assignment statements. Then calling r dot compute rect, right? This method is called area is computed, and the area is stored in a rectangle class object, say r dot area. Then r dot disk means, right, what happens means r is a rectangle class object. We are calling disk method, its one method. So computing area of rectangle, that message is displayed. This calls the subclass version. R dot display means what happens? Display is actually not available in the class rectangle, but display is a method of superclass. Since this is in a public scope, all public methods are once again available in the extended class, say rectangle class. So R dot display, this calls the version available in the superclass. So in the where is superclass? Yeah, in the superclass, the variable area is printed. Area is equal to plus area. But however, area is computed, right, using the compute rect method, r dot compute rect of subclass method. But one thing, t dot disp, this results in compile time error because t is a triangle class object and disp is a method which is available in the subclass, superclass reference variable or the superclass object cannot directly access the subclass methods. T dot disp results in a compile time error. Superclass object can have the rights to access only the superclass instance variables and methods. This is a simple example to illustrate Java's simple inheritance. What is a file name? File name is inheritance1.java. To run it, use Java inheritance1. Area is computed for first triangle class, then area is computed for rectangle class. You please understand, right? This is a syntax to perform a simple inheritance. What is the syntax? Class name. What is the class name? Class name is subclass instance superclass. Then what is this? Additional members of subclass. That is additional members of subclass. Other than that is superclass members with respect to public data we explore, right? What is protected? Public access group are available here, are inherited here. As subclass extends superclass name. Then the members of a subclass, you need to define the additional members of the subclass. Don't redefine the same members of a superclass here. Then it comes under a concept of method overriding or variable overriding, instance variable overriding. We explore, right? This is a simple example of a simple inheritance. Private variables cannot be inherited, right? For example, if you want to access the private variable z here, right? Printing the value of z inside the class rectangle, right? That results in a compile time error because private variables cannot be inherited into the corresponding subclasses. Next question, right? We need to see the relationship between superclass reference variable and the subclass object. The topic is the relationship between the superclass reference variable and subclass object. Because Java supports compile time polymorphism and runtime polymorphism, the key concept to achieve one interface multiple methods aspect of polymorphism, right? Particularly one interface multiple methods aspect of here with respect to inheritance, runtime polymorphism. To achieve that, we need this key concept. Can a superclass reference variable or can a superclass variable reference a subclass object? This is the question. The answer to the question is yes. Superclass reference variable can reference or can point a subclass object. This is perfectly valid. For that, what we have to do means we need to define one reference variable of a superclass. Then define the subclass objects. How will you define a reference variable? How will you define a reference
Cla-
variable?
uh, Class name and object name.
A class name, a space, some name, right? That is a reference variable name, semicolon. New operator should not be introduced. Then it acts as a reference variable. So try to define a reference variable like this, superclass name, space, some reference variable. Then define the subclass objects. Clearly the reference variable can be assigned to the subclass object. Then using that reference variable dot method means, right, assuming that that method is a subclass method, then we can call the method which is available in the subclass using a superclass reference variable. So this is perfectly valid. Now, let us come to the concept. Superclass reference variable, right, can point or reference, can access, can assign a subclass object, right? So subclass object are in reverse. Subclass object can be assigned to the left-hand side, the superclass reference variable. This is valid. To illustrate that, we consider the same example. Class triangle members are defined, right? As we defined earlier. Then class rectangle extends a triangle. The rectangle members are defined. Then inside the main, as usual, right, we defined triangle class object is created. Using triangle class object, you can access its own members. This is valid. Now on in a reference variable, that is, this is an instance, right? This is not an object or simply but on a reference variable. For the superclass triangle is created. Class namespace reference variable semicolon. Now you can create an object of rectangle class. Rectangle R is equal to new rectangle, right? As usual, right? We can call the methods of rectangle class as well as the inherited methods of rectangle class. That can be done here. Same as previous example. T dot display already we explored because T is what one? A superclass object. A superclass object cannot directly access the subclass methods. This is invalid. Compile time error. But this statement is valid. Very important statement. This is uh, a superclass object, right? Object is T, right? Superclass object can also pointing to a subclass object. T is equal to R, right? Valid statement. T dot compute, then a T dot display, right? This is a valid statement. But the main important statement is T1. What is T1? T1 is an instance of a superclass reference variable. T1 can point a subclass object. T1 is equal to R. Left hand side is a superclass reference variable. Superclass reference variable. Right hand side is an object of a subclass one. Subclass object. Superclass reference variable is equal to a subclass object. Now T1 dot display. T1 superclass reference variable. What is a display? Display is a version which is available in the superclass, right? Here void display, but during the inheritance, T1 is equal to R means, right? What happens? The subclass object R is assigned here. So by assigning T1 is equal to R, T1 dot display calls the version of a display here. Display is available in which version? Display is available
Superclass.
in
Superclass, sir. Triangle.
actually in superclass, but yes, display is actually available in the superclass. But here T1 is equal to R means what is the concept? T1 is pointing the subclass object. So T1 dot display means what will happen means the version which is available in the subclass is going to be called. This is very important. In C++, can you recall that the virtual function concept? Base class,
Yes, sir. Runtime
base
polymorphism
class,
and
base class object pointer is created. Yeah, polymorphism. Yeah, same concept. So if we extend right this into some more extended classes, right? So when the superclass object is pointing, for example, first subclass object, superclass reference variable dot method name means first class version is called. Then superclass reference variable is pointing some second subclass object. Then the same statement will call a version available in the second subclass. Then the same statement may call a version available in the third subclass if and only if the superclass reference variable is pointing the third subclass object. So don't think that T1.display calls a version of the triangle class. It's not. T1.display actually calls the version which is available in the subclass rectangle. Why means T1 is pointing the object of a rectangle class. So T1 dot display means the version which is available in the subclass is going to be called. That is, a rectangle class is going to be called.
Sir, but we are not having any
The
function
code
in the rectangle classes.
Java C
Display function is on.
pattern. Yeah,
So display
this
function is
question is good. Wait, I explain. Wait. Java not available in rectangle. Yeah, wait, I explain. Java inheritance 2. Rectangle, yeah, display which is not actually available in which one?
Rectangle, sir.
Class.
Yes,
It's
sir.
not available. But calling here, see, yeah, not available in rectangle. T1 is equal to R. What is R? R is the rectangle class object where we initialize R. R dot X, have a look into the statement. R dot Y. R dot X, R dot Y are initialized, right? T1 is equal to R. Now, assuming that one method which should be called, right, T1 dot compute rect. Can we call T1 dot compute rect?
yes, sir.
Is it possible to call T1 dot compute rect? How can we call T1 dot compute rect? T1 dot compute rect. Let us save the file. This is not possible because the T1 is what one? An object of a superclass, that is, sorry, reference variable of a superclass. Reference variable of a superclass cannot point any of the subclass methods. It cannot point directly the subclass methods. T1 dot compute rect. This results in error. But we can ask a question, right? A display is actually available in the superclass. But how can we say, right, the rectangle class version is going to be called? For that, right, how should we resolve your question?
Sir,
How can we ensure that
sir,
display
the
T1 dot
appropriate
display
the appropriate area
actually calls the version available in the rectangle class?
the
Appropriate,
appropriate area, whatever the area value according to the rectangle variables will be called, sir. Means the area value, whatever it is computed by the rectangle instance variables displayed.
yeah, yeah, very good. That is the answer. Here, right, have a look into the statement. System dot out dot println area. So in this stage, what will happen means the value of a variable area is invoked, right? What is the invoking object? Invoking object is T1. T1 dot, this is not T1 dot area. That's what I said, right? Since display is a part of rectangle class, in that stage, rectangle class area is called, right? So you try to note it in the result 156.25, again 156.25, right? So try to understand that I think the value T1 dot display, right? This displays the actual area of a rectangle 156.25, not the area of a triangle 0.5 into x into y.
Sir, what is happening when we are calling with T dot display, sir? To R
Having
and T dot display.
T dot display, each one, this one, T dot compute and T
Yes,
dot
sir. Yes,
display.
sir.
T dot display means the triangle class version is called, because a triangle is a T is an object of a triangle class, right? So T dot, here this statement T dot display means triangle class version is called, because currently T is an object of a triangle class. But have a look into the second statement. Don't confuse here this T dot display. Since T is pointing the object of a subclass, T dot display calls the version available in the subclass. That's what you can find that last two lines of the output. 156.25 and 156.25 corresponds to the area of a rectangle, not area of a triangle. Area of a triangle is computed here, right? For example, here t dot compute and t dot display. Since here the superclass reference variable is directly assigning the subclass object, right? Our superclass object T can also directly pointing the subclass object. This is a valid statement. T is equal to R. Having any other queries?
Sir, I have a doubt, sir. Sir, when we are calling t dot compute, sir.
Okay.
Sir, after calling t dot compute, you are calling display, no, sir. So t dot compute has a different value because we are using 1 by 2 into x into y.
Yeah.
And t dot display.
Which one? First line. This one.
Yes, sir. Not
See
that one,
one
sir.
minute.
Not
I
that one,
explain.
sir. After assigning,
T dot compute calls the version.
not this one, sir.
Which line are you pointing?
After t equal to r, we are writing t dot. Yes, sir.
This one. Yeah, T dot compute. This calls the version available in the rectangle class. T dot compute.
Here t dot display and t1 dot display should not be
This
same.
calls the version available in the rectangle class.
Sir.
T dot display and T1 dot display. Last two lines. 156.25, 156.25. Same. Because here T is pointing rectangle class object. Here T1 is pointing a rectangle class object. So both are printing the same results. That's what I say. T dot display, T1 dot display. Last two lines of output corresponding to the
Sir, then what
rectangle
is the
class
use of
object.
reference variable, sir?
Previously, what is the use of?
Reference variable.
Sir.
What is the use of? Can't hear you. Reference variable. Good question. In C++, right, how do you achieve a runtime polymorphism using virtual function concept? I think time is out, right? Using virtual function concept, you are going to achieve a runtime polymorphism. But in Java, the superclass reference variable, since it can be assigned to a subclass object, and this forms a key concept in achieving the runtime polymorphism, which is characterized by one interface and multiple methods. Okay, in the next
But
class,
we are
we
not
will
achieving.
explore how Java supports this kind of one interface multiple methods.
Sir, both methods
Not achieving?
are similar only, sir.
Yes,
Like,
tell me.
Sir, actually in runtime polymorphism.
In this example, we are not achieving the runtime part. Yes,
Sir,
tell
but in
me.
runtime polymorphism, when we are when
In runtime polymorphism,
in runtime we are able to call the methods, no, sir, with a pointer of subclass. With a pointer of superclass, we are able to call the
yeah,
methods inherited class, no,
yeah,
sir. That is derived class. But here we are not able to achieve that, no, sir, because when we are calling people dot
yeah,
display.
yeah, that's what, right? See, even in this example, right, I try to write two more statements. Say triangle T1, right? Triangle T1. Time is out, right? So I explain directly. When T1 is pointing T, right? Have a statement T1 is equal to T, right?
Yes, sir.
Calling T1 dot display calls the version available in the triangle class. Understand? T1 is equal to T semicolon. T1 dot display calls the version available in the triangle class.
Yes, sir.
Subsequently, T1 is equal to R, but T1 dot display calls the version available in the rectangle class. You have to understand T1 dot display initially called the version available in the triangle class. After some statement, T1 dot display calls the version available in the rectangle class. Similar to buy a ticket at different situations. If you are in the station, right, if I ask you to buy a ticket, you will be buying a ticket, right? A railway ticket. In theater, right, if you are right, if I ask you to buy a ticket, you will be buying a right film ticket. So buy a ticket, only one query,
Sir,
one executable statement will respond at a
Sir,
different
but actually in
situations, different actions. So one statement can
sir,
call,
here we are using reference variables.
yeah,
Uh, here we are using a reference variable and we are calling the we are able to call only the superclass methods, no sir, with that reference variable. But in runtime polymorphism, we can also call the derived class methods, sir. But here we cannot do that one, no sir.
see for that, right, we explore in the next class, right, what actually the runtime polymorphism is,
Yes.
right? For example, in class triangle, right, we have one person display.
Yes, sir.
You need to define, right, the thing is, right, since in the class rectangle no display is there, that's what you are not understanding, right? Whether
Okay.
it is
Okay.
actually called the display version of rectangle, that is the question.
Okay.
For that, what you are to do is try to define same display inside the class rectangle.
Okay.
Understand?
Okay.
Print the message, display inside the class rectangle. Okay.
Okay.
Here print the message, display inside the class triangle.
Okay, sir.
Hope you understand.
Yes, sir. Yes.
Then you try to run the code and check the results. You will be seeing the message which is available in the class rectangle because method overriding is taken place. So superclass reference variable dot subclass, the method means subclass version is called, so that you will get a clear understanding, right? So here,
Yes.
right, I try to explain the key concept to achieve a runtime polymorphism. The key concept that you need to understand is this one. Superclass reference variable can point a subclass object. Then superclass reference variable dot some method name means the method name, right, must be available in the superclass. If not, right, it should be redefined in this class as a method overriding concept.
Okay,
So
sir.
anyhow, right, in the next session, right, we will complete a runtime polymorphism concept.
Thank
Okay,
you, sir.
thank you very much. If you have any other queries, right, you try to ask me.
Thank you, sir.
thank you, sir.